All right, y'all. So 7.5 officially is called analyzing graphs. Of quadratic functions. Okay, y'all. So I'm going to draw a graph here. I keep getting people coming in. And y'all, I'm just drawing a basic parabola here. So say I have a parabola just coming down, touching my x-axis. In this point right here, we'll say that that point is 3, 0. So that minimum point, or if this graph is flipped over and you get a maximum point, that point right there, y'all, is the vertex of the parabola. Okay, so it is the minimum or maximum point of the parabola. So since it's a point, remember, this vertex will have an x value and a y value, okay? Now, these x and y values of the vertex are going to come in handy. First thing is what we call the axis of symmetry. So y'all, this x value of 3 on that vertex, if I was to draw an imaginary dotted line through that x value, notice what happens. This graph is now symmetric to that line. Just like when we were looking at symmetry to the y-axis. Well, this is now symmetric to this line that I drew here. And that line would have the equation of x equals 3. Remember, vertical lines are the lines we got from the x values last chapter. So if I made that imaginary vertical line, it cuts the parabola in half. So this is an imaginary line that cuts the parabola into 2 equal sides. Now, the axis of symmetry comes in the form of an equation. We always seen that right here. We drew the line, and I said that that line was equal to the line that you would get from x equals 3. So that means that they come in the form of an equation, x equals some number, where x will be the, a will be the x value of our vertex. So in this situation, remember, my axis of symmetry was this line, x equaled 3. So that's what the x value does. It gives me that line of symmetry. This parabola also gives me a minimum or maximum value. So it's going to determine the minimum or maximum value of the parabola. And y'all, that is equal to the y value of the parabola. Or how about of the vertex? Well, remember, y values are always the amounts. Like when you was doing pay, your hours were your time, which was your x's, but the amount of your paycheck was your y values. So this parabola that we have right here would have a y value minimum of 0 because that's the lowest y value associated with that graph. All right. Now, how do I determine if I got a maximum or minimum? Well, y'all, here's what we do. If the x squared term is positive, then you're going to have a minimum value. Because if the x squared term is positive, your graph is going to open upward. Now, if you remember from 7.2 when we were looking at the transformations of the graphs, if I put a negative in front of that x squared, remember that negative took the graph and it reflected it over, which means if the x squared term is negative, that's flipping my graph over. And if it flips my graph over, then I now have a maximum. So my graph, my parabola will be almost like a mountaintop there. Okay. So this first example, they're going to give us a picture and we're going to find our vertex, axis of symmetry, min or max value. After this problem, I'm going to give you a formula that we use to find the vertex. Okay. So this one's going to be just a drawing basically like I did here, wanting me to identify those things. So we're going to use the graph of the quadratic function. And they're telling you that it's the graph. When they say quadratic function, they're just using a formula here. This has nothing to do with the problem. They're just showing you that it's a quadratic function that's being squared, okay? That exponent 2 is telling me it's being squared. The h member is going left to right, and the k would be the part going up or down. And remember, a could be positive or negative 1 or something like that, okay? So they're just giving you the general equation, but we don't have to know nothing about that. We're just going to look at the picture and we're going to find the vertex. We'll find the axis of symmetry. And then the min or max value. Okay. Now we don't have to tell whether it's a min or max because the graph will show us when we graph this. So they got a graph here. And we're going to go out about 5 each way. Now, y'all, over here at 3, -2 is my minimum point, and they actually give you that point. And then, y'all, this graph just sort of goes uphill. But y'all, all we're worried about is what this point is for that vertex, that 3, 2. So the first thing they want is that vertex. Now remember, you gotta write it just like this is as an ordered pair. So since 3, -2 is the minimum point of that graph, my vertex is 3, -2. Next, they wanted the axis of symmetry. Now remember, it has to come in the form of an equation. So you gotta put the x equals in that answer. Sometimes MathLab will draw the x equals, but just look at the answer blank and see what they're doing, okay? Well, remember, we said the axis of symmetry was equal to the x value of the vertex. Well, y'all, my x value is 3, so that means the axis of symmetry is x equals 3. If I drew that imaginary dotted line at 3, it cuts our parabola in half. And then finally, min or max value. Well, we know it's a minimum because we got a little valley sitting here. But remember, the min or max value is equal to that y value, which is -2. Now, it don't have to come in the form of an equation. It just has a minimum value of -2, and that's all we need to put, okay? So that's the type of stuff we're going to be doing on this. But y'all, we're about to do it by formula and not by the picture, okay? So we like it when they give us a picture with everything labeled. So what happens when we're doing it by hand? Well, y'all, we got what we call the vertex formula. So this will be the vertex formula. Now, remember the vertex is an ordered pair. It's got an x and a y value. So the vertex is going to look like an ordered pair when I'm done. To find the x value, I'm going to use the formula -b over 2a. And y'all, if you remember, the quadratic formula had -b over 2a on it the other day, remember? Now, once I find that x value, I plug it back into the function they're giving me. So that means I'm going to be finding f of that -b over 2a. Okay? So we find the x value, then we plug it back into the function and get the y value. Now remember, in the formula, you got a b and an a. A is always in front of the x squared term. B is always in front of the x term. Now the c is not really in the x value of the formula, so your main thing is get that a and b right when you're plugging it in, okay? Now remember, if a is positive, if that a is positive, y'all, I'm going to have a minimum. And if the A is negative, then I'm going to have a maximum. Because remember, the A is in front of the x squared term, like we said a while ago. So that sign tells me everything about whether I got a minimum or max, okay? So let's play with one of these. So the first thing they'll want us to do, we're going to find the vertex. We're going to find the axis of symmetry. Now, sometimes they might say line of symmetry instead of axis of symmetry, but the same thing. All right, then we're going to determine if a minimum or maximum and the value so we have to tell it, okay, you got a maximum here. What's the value? Or, hey, we got a minimum here. What's that value? And then the last thing, we're going to graph it. Now, I will say in here, when you graph the parabolas, you got to have 3 points. Well, this vertex will be one of the points. We just got to find 2 more. Usually what I do is I'll just graph it in my y equals, go to my table, and get 2 other points other than that vertex, okay? By hand, I would just plug in numbers like zeros and ones, see what kind of values I'm getting out of those. So y'all, the first one they're giving us, f of x equals x squared minus 8x plus 7. So I'm going to figure out A, B, and C so that I can start finding these x and y values. So A would be 1 here. B will be -8. And C is a positive 7. Now, y'all look here. That A is positive. We said right here, if the A is positive, we're going to have a minimum. So I'm going to just draw my parabola there to remind me that, hey, I got a minimum here because of that A being positive, okay? All right, y'all. So first, let's work on the vertex. Let's get the X value. Because remember, I can't get that Y value until I know my X value. X value is -b over 2a. Now remember, just like the quad formula, that negative is always in the formula. So write the negative, then put in your b. So my b is a -8. So that's basically going to give me 2 negatives there. And y'all, what's that going to do? Make that all positive, right? So that little negative in front of that b, its only purpose in life is to change the sign of the b in your formula. Now, 2 times 1 on the bottom. So y'all, like we said, that's going to give me a positive 8 over 2, which gives us a positive 4. So now, I'm going to put my vertex here. I know the x value is a 4. Well, if -b over 2a equals 4, that means we're about to find f of 4. So f of 4 is how we're going to get the y value. So that means take your function up here, put a 4 in for both of those x's. So y'all, that'll be a 4 squared minus 8 times 4 plus 7. Now, at this point, if you want to, you can plug that right into your calculator. It'll spit out the answer fast. By hand, 4 times 4 is 16. Minus 8 times 4 would be minus 32. And then plus my 7. So y'all look here. 16 minus 32 is a negative 16. Negative 16 plus 7 gives us a negative 9. So I now know my vertex is a positive 4 and a negative 9. Alrighty, so that's my vertex. Next, they wanted the axis of symmetry. Well, we're good to go because we got the vertex now. And we know the axis of symmetry is always equal to the x value of the vertex. So y'all, that's just going to be x equals 4. Now remember, got to be in the form of an equation. If they don't put x equals there, you got to. All right. A was positive like we said, so we know we got a minimum. So this one is a minimum of, well, y'all, what's it a minimum of? Whatever that y value was. Well, my y value was negative 9. So that means I got a minimum of negative 9. That's the lowest y value on that parabola. Every other y value is higher. Now comes the part where we graph. All right, so I might graph that on an actual graphing paper here, okay? So the only point I got at the moment is my vertex is 4, negative 9. So I'm going to need a couple more points, y'all. So what I'm going to do to get my other points, I'm just going to, we all got that calculator in here. So I'm just going to go to y equals and graph it and then get me 2 points. So I got my x squared minus 8x plus 7. All right, y'all, let me let one in real quick. And then let me backspace. I got too many numbers there. And delete. All righty, so I'm going to go to the table. Now, remember, my vertex was 4, negative 9. So when I hit second graph and go to the table, I'm going to arrow down until I can find that 4, negative 9. So 4, negative 9 was my vertex. I need 1 point on each side to finish this. And y'all look on the left side, 3, negative 8. And then on the bottom, you got 5, negative 8. So I'm going to use 3, negative 8 and 5, negative 8 as my other 2 points. But y'all, you see the symmetry? Any of these points on here you can use. Okay? And they don't have to have the same y values. You could use 2, negative 5 and then do 5, negative 8, 6, negative 5, whatever you want to do. I used to just try to find a point on each side of it. All right, I got y'all. All right, so this goes out 10. My first point, 4, negative 9. Y'all listen, in MathLab, you're going to pick the 3-point quadratic tool. Remember, 4, negative 9 was my vertex. The vertex that you just found has to be the first point we graph in MathLab, okay? So graph that 4, negative 9. So go right 4 and down 9. So that's going to put me right here. Then 3, negative 8 will be right 3 down 8. And then when you come in and put the last point, 5, -8, Math Lab at that point is going to draw your parabola for you. But y'all, vertex first in here. Because some of these problems, the order don't matter, and you can put them in any order. But on a few of them, it definitely gets picky on that vertex. So always just plot it first just to be safe. Now, remember, we did that on the calculator, and we didn't graph it yet because I wanted you to see what we just drew. And then when we look at the graph on the calculator, there you go, to the right. And down there at that 4, -9 is our vertex. So y'all, question on that one. All right, so let me keep us going. So this next one, we're going to find the same thing, the vertex, axis of symmetry, min or max and value, then it'll want you to graph. So y'all, we're given f of x equals 2x squared plus 14x plus 24. And y'all, I'm going to write the vertex formula up here for us. Negative b over 2a, f of negative b over 2a. So this is going to be a fun one, and it's got special numbers that y'all really love, okay? So let's get the vertex for that x value. Well, y'all, negative b over 2a. Oh, we got to put a, b, and c here. Well, I forgot that. A is positive 2, b is 14, and c is 24. So the a is positive again. So remember, since a is positive, we definitely got a minimum on this one. All right, y'all, so here we go. Got my negative. This time b is a positive 14. So the negative in the formula turned that positive 14 to a negative 14. And then on bottom, 2 times a, which is 2. So y'all, I'm going to get a negative 14 over 2 times 2 is 4. So you can't divide that, but y'all, we got to reduce this. If they got any common factors, you got to divide those out. And y'all, both of these ones will divide by 2. So I'm going to reduce this fraction by dividing by 2, because that's the largest factor they got in common. So that'll give me a negative 7 over 4 divided by 2 is a 2. So for my vertex, the x value is a negative 7/2, which means now I'm finding f of a negative 7/2. That way I can get my y value. So f of a negative 7/2. So y'all, unfortunately, we're putting that negative 7/2 in for both of these x's. So 2 times negative 7/2 squared. So there's my exponent. Plus 14 times negative 7/2 plus my 24. Now, y'all, here's the thing. At that point, you could plug that right into your calculator. And it'll spit out. If it gives you a decimal, you got to turn that back into a fraction by hitting math and enter. But hey, I'm going to do this by hand. Give y'all some practice with exponents. So priority goes order of operations with that exponent sitting right there. So bring that 2 down. That 2 is not inside the parentheses. So it's coming down. It's not affected by the exponent. Now I got a fraction raised to an exponent. You're going to square the top and you're going to square the bottom. Everything in these parentheses is getting squared by that exponent. And any number you square better be positive, y'all. So -7 times -7 is a 49 over 2 times 2, which is 4. Now, I'm not doing any other steps than that exponent, so y'all can sort of follow what I'm doing here. So the exponent's done. Now I'm going to multiply. Now this 2, you better treat it like it's over a 1. And this 14, treat it like it's over a 1. Because the 2 multiplies by the top number of the fraction. So 2 times 49 give you 98 over 1 times 4, which is 4. Now here, you got a 14 times a -7/2. That's going to be negative. So 14 times 7 is a negative 98 over 1 times 2, which is 2. And then I didn't do nothing to the 24, so I'm just going to bring it down. But y'all look here. Now we're going to have to add these numbers together. So I got to put a 1 under the 24 to make it look like a fraction. And before I can add these 3 numbers, they need to have a least common denominator. So usually on this problem, your least common denominator will be the largest number. Okay, because I can turn a 4 is already a 4. I can turn a 2 into a 4, and I can turn that 1 into a 4. So this least common denominator for this problem will be a 4. So first fraction already has a 4 on the bottom. So bring it down. Now, to turn that 2 on the bottom into a 4, I'm going to have to multiply the bottom by 2, which means I'm going to multiply the top times 2. So 98 times 2 is a 196. 2 times 2 is a 4 on the bottom. Now we got to change this one into a 4 on the bottom. So I'm going to have to multiply that bottom by 4, which means I'm going to multiply the top by 4. So 24 times 4 gives you 96. 1 times 4 is 4. So y'all with me? I don't mind multiplying fractions up here, but adding fractions is where it's really picky about having a common denominator, okay? All right, I got 3 things with a 4 on the bottom. So when I add and subtract on the top, I'm going to have a 4 on the bottom at this point. So let's see. 98 minus 196 is a -98. -98 plus 96 gives me a -2. So all this gave me a -2/4, which will simplify. Remember up here I had 14 over 4. I divided out the 2's, made that a 7/2. Well, both of these numbers will divide by 2. So that I get a -1/2. So my vertex is a -7/2, -1/2. So, y'all, this is probably the trickiest one because of those fractions, okay? But it's not a bad problem to give you fraction practice, I guess. All right, so what do we got to do? Our vertex, well, we know the vertex was -7/2, -1/2. So how about our axis of symmetry? Well, that's going to be x equals my x value, which is -7/2. Y'all, really, once you found this, you've got everything you need, okay? All right, then I got to know, is it a minimum or maximum? Well, we said A was positive, so we would have a minimum. So we have a minimum of my y value, which was -1/2. So same thing over here. I'm about to graph that one right here. -7/2, -1/2. Now, let me go find some more points to use for this one. So I'm going to go to my calculator, go to y equals and clear that out. So this one was 2x squared, so 2x squared plus 14x plus 24. Now, I'm going to go to the table first. Now, notice these y values are getting bigger. Whoops, go back to my table. The y values are getting bigger if you go down. So I'm going to go up and see if I can't find. Now, do y'all see how there's 2 zeros in a row for them y values? Look at the x value. One's -4, one's -3. Well, if you was to figure out what -7/2 was, it would be a -3.5. So it would technically, my vertex would be in between the x values of -3 and -4 there. But y'all, I'm going to use them points, -3, 0, and I'm going to use -4, 0 for my other 2 points when I graph this. All right, so remember, in MATLAB, you're choosing your 3-point quadratic tool. Now, the easiest way to graph these is probably to turn them into decimals. -7/2 is a -3.5, and -1/2 is a -0.5. So -3.5, here's -1, -2, -3. On MATLAB, -3.5 will be right in between those, okay? And then that -1/2 would go down so that my first point is right there. Y'all, that I was just showing you where the -3/2 is. But the first point is right here where I went down -1/2. That is my vertex. Now the other points, -3, 0. So -1, -2, -3, 0 right there. And then -4, 0. So 1, 2, 3, 4. So see how that -3.5 is in between -3 and -4, okay? So y'all don't put the point on your graph when you're drawing them. I just wanted y'all to see where that was on that x-axis. So this graph is going to come uphill. So if we go back and look at the calculator, when I hit graph, oh, there it is right on that left side. Okay, so let me show y'all that. So a question was, what if I wanted other values other than using the calculator? Well, that's when you go old school. Now I do know I would pick values. Me personally, I always pick values close to these X values. So since that -7/2 gave me basically a -3/5, I would probably pick a -3 on one side and a -4 on the other. Now, guess what? To get those Y values, I'm about to plug those numbers into here. So I'm going to find f of -3, which will be 2 times -3 squared plus 14 times -3 plus 24. All right, so remember, -3 squared is 9. 9 times 2 is what? 18? Are y'all with me? Now,
Yes.
14 times -3 gives me a -42, and then plus my 24. So let's see what we get. 18 minus 42 is a -24 plus 24, which gives me a 0. So we'll get the same values the calculator had. We're just having to plug our x's into that and getting those values. So my other one was what? F of -4. So 2 times -4 squared plus 14 times -4 plus 24. So y'all, -4 squared is 16. 16 times 2 is 32. Right here, 14 times 4 is going to make that a -56. And then at the end is what? My plus 24. Now I know this is going to give me a 0, right? 32 minus 56 is -24. -24 plus 24 gives me a 0. So Vidi, that's really the way to do it by hand, but you can pick any x's you want, okay? Personally, like I said, I try to stay close to what my vertex is, okay?
Okay, thank you.
Okay, so a little bit more work, but it ain't impossible. Now, I will say another way that you can get 2 points is doing a quadratic formula. But sometimes if you get radical answers, you just wasted your time. So we'll always try to keep it something close to that I know will work. All right, y'all.
I'm sorry, I had a question.
I hear you.
So you suggest that we don't use the quadratic formula for these problems? Is that what you're saying?
Well, it would have worked on that one because those two values gave me a 0 for those y values.
Mm-hmm.
But sometimes, sometimes let me show you something here. So sometimes I have graphs that go up like that.
Mm-hmm.
They don't even cross the x-axis.
Mm-hmm.
These ones like this would have those imaginaries. Remember the I stuff we got the other day?
Mm-hmm.
Well, where the hell you gonna plot a 2i at? Or a 3 plus 7i? We can't plot imaginary zeros. So yeah, you're sort of messed up if it's got imaginary zeros because it's not crossing this.
Mm-hmm.
Or what if you got zeros that look like x equaled 2 plus square root of 3? Where y'all putting that on that x-axis?
Oh, okay. I see what you're saying.
Yeah, so sometimes these, sometimes we got numbers that are impossible to sort of find with that quad, okay?
Okay. Thank you.
All right, no problem. Oh, we need what? A min or max and a value. And then they want us to graph that. So y'all, this one is f of x equals negative x squared minus 10x minus 27. So let me get my A, B, and C. Well, y'all look at this. A is now -1. B is -10. C is a -27. So here I go. I'm going to get that x value first for the vertex by doing -b over 2a. And we're probably hoping we don't get a fraction for this answer. So y'all, let's see what happens. I got my negative. My b is a -10. So that's going to give me two negatives again. Over 2 times -1. Now, before I go further, I want to know, will I have a minimum or maximum on this? Now, that's not the picture for this graph. I was just showing y'all something a while ago. But this A is negative, which is flipping the graph over. And I'm now going to have a maximum value on this one, okay? All right, y'all, let's see what happens. Negative, negative makes that a positive 10 over -2. Oh, and that's all right, because that gives us a -5. So, not a fraction on this one. So, to get my y value, I'm going to find f of that -5. That'll equal negative times -5 squared. Now, y'all notice this. That negative is in front of that x squared. So, you got to bring the negative down, then put in your x value. Then I got -10 times that -5 minus 27. So y'all, let me ask you this. How many negatives do y'all see here? In all reality, how many negatives are here?
2,
Well, you see two of them, don't you?
right?
But what's that exponent 2 doing?
Multiplying the -5 to turn into a positive
Okay.
10.
So
Is it
what
canceling them out?
So what we really got here is a negative here, a -5, and another -5, right?
Right.
So you really got 3 negatives here, not just 2, because of that exponent. So let me show you what's going to happen. You would think this would end up positive, right? But watch this. Bring that negative down. Now, square this -5. Well, -5 times -5 made that a
25.
25. So this answer will stay negative because in all reality, y'all, there's really 3 negatives here because of that exponent. All right. Now, I'm just doing the exponent, so I'm bringing everything else down for the moment. Now, I'm going to do my multiplying in the middle. So bring down that -25. Minus 10 times -5. That'll make that a positive 50. And then minus my 27. All right, so let's see. -25 and 50 give me positive 25. Minus 27, which is what, a -2. So my y value is now -2. So let's do the axis of symmetry. All right, so what is my axis of symmetry?
-5.
Oh, you're so close.
X equal -5.
X equal -5. There you go. I'm gonna be mean like Math Lab. Well, we said we had a maximum value up here. So y'all, what is my maximum value?
-2.
So maximum value of -2. Now I'm not going to graph this one, but I'm going to show you my points I would pick. I know the first point's going to be that -5, -2 for my vertex. Now, if I want to keep numbers close to that -2 without having a big graph to draw, I would probably do -6 and -4, one on each side of that. So f of -5, I would have my negative and then my -5. Whoops, I'm not doing -5. I'm doing -6, my bad. So negative and then my -6 squared minus 10 times my -6 minus 27. All right, y'all. -6 squared is 36. Times that negative is going to make that a -36. And y'all, I don't care if you put a positive number or a negative number into this equation with that negative there, it's always going to end up negative. Minus 10 times -6 will be plus 60, and then minus my 27. So let's see what we get. -36 plus 60. Yo, that's a positive 24. 24 minus 27 gives me a -3. Now, y'all, let me tell y'all a trick. The reason I'm picking numbers that are on each side of this, these graphs are symmetric. So if this one number to the right of that gave me -3, guess what the number one to the left is going to give me? It's going to give me -3 again, right? Remember a while ago when we done the two numbers I said were next to the 3 halves? Well, they both gave me 0. So we know for sure if we was to plug in that f of -4, and y'all, that's what I want y'all to see why I'm picking these numbers that are on each side, okay? That'll give me 16, that'll make it -16. Negative times negative is a positive 40 minus 27. Well, y'all look at this. -16 and 40 give you 24 minus 27, which give us a -3. So I sort of want y'all to see ways you can cheat on these. Whenever you get one number to the right, you're going to get one number to the left, okay? So plot that vertex, plot them 2 points, and be done with it, okay? Let me get my paper fixed, y'all. Oh, y'all, let me ask y'all, true or false? See what y'all say on this, true or false. The function f of x equals 4x squared minus 3x minus 8 has a maximum value.
False.
Oh, perfect. And you're saying false because
The A is positive.
the A is positive, y'all. That's a positive 4 sitting there. And we said when that was a positive 4, that thing's going to have a Good job. Minimum, right? So that is definitely false. So one more of these, they're going to have 2 or 3 of these, I think. I'm just going to mess with y'all with this one. So the graph h of x equals x plus 3 squared can be obtained by translating the graph h of x equals x squared left 3 units. So this question basically comes out of the 7-2 stuff where we move stuff up and down. We moved it left and right. So the basic graph was the x squared graph. So what happens when I add 3 inside them parentheses? Is it going to go up, down, left, or right? Is this true or false? So y'all slept since y'all done that homework, huh?
Would it go left?
It's going left because remember, when you add to the x inside parentheses, it actually goes left, which means they said left 3 units. So this one is actually
True.
true. All right, let me see what that chat said. So chat said true. Good job. All right, y'all. So before we can do the next problem, I got to show y'all what we mean by intervals of increasing, decreasing, and all that fun stuff. And this is sort of what the support's going to go over. 3 problems doing this. So this is intervals of increasing, decreasing, and I'm actually going to do constant also. Actually, on parabolas, they won't have a constant. Ooh, my thing keeps clicking. But I'm going to show you this because of the support. Now, you gotta read the graphs left to right. Okay. So left to right, even if they got arrows going one way, you read that graph left to right. Those arrows just mean that the graph goes on forever and ever and all that fun stuff, okay? Read those graphs left to right. And when I talk about range, I'm going to talk about it. It goes from the bottom up. Now, let's look at the intervals of increasing. We're going to do them first. Now, when I talk about the intervals, all I care about are the x values where this happens. So an interval of increasing is the x values where the graph goes uphill left to right. So it's going to sort of go uphill left to right. So in the interval, we'll have parentheses. We'll have the starting x value. Then we will have the ending x value. Okay? I don't care about y values. I only care about where on those x's is my graph going uphill, okay? So how about intervals of decreasing? Intervals of decreasing is the x values where the graph goes downhill, left to right. So downhill. So guess what? You're still going to have a starting X value and a ending X value. Once again, no mention of Y values. And y'all, the next one will be for the support only because parabolas don't have this part. But this will be intervals of constant. So remember, constant means the values stay the same as you go across. So these are going to make a horizontal line. So this is going to be the X values where the graph is horizontal left to right. And remember, horizontal is just straight across. So you'll have a starting X value and a ending X value. So starting X value and your ending X value. Okay. Now notice on these intervals, I'm using parentheses. So y'all think about this. We're going to be dealing with parabolas. So say I had this parabola here, and here's my vertex. And say my vertex on this parabola is A, B. I don't know the numbers. I'm just putting an A and a B here. So, increasing. Well, y'all see the right side of this is going uphill, right? This side is increasing. This side, although I got an arrow, if you read this left to right, this left side is going downhill. So the increasing interval starts right here and goes up. Well, guess what? Where it starts going uphill, ain't that the X value of my vertex? So when you're dealing with a parabola that's facing up, your increasing interval will start at the A, the X value of the parabola. Now, y'all, let me ask you this. Follow me. My X's are going this way. My X's keep going that way. This graph is going to keep going up forever. Where are my X's headed towards? Oh, I think I'm hearing, but I ain't hearing very good. It's real soft. So where am I going toward the right as I keep going and I keep going and I keep going and I keep going?
Is that called like infinity or something?
Oh, I'm going to call it infinity. Good job. And I'm on this one decreasing. Well, it's decreasing on this side as these X's come in. It's going to decrease until it gets to that X value. So where are we coming in from on the left side?
Negative infinity.
So negative infinity. And guess what? It's going to go on the x-axis till it hits your vertex.
Yeah.
A. So the X value of the vertex is the point where these intervals cross over. Now, what if this was upside down parabola? And I'm still going to call this point A and point B, okay? Now, if the parabola is upside down, it's not increasing on the right side no more. It's increasing on the left side here, right? Although they got arrows, this is increasing on this side till it gets to that point. Which means as I come in from the X's, my graph is increasing until it gets to that X value of A. So where's this one starting in from on the left?
Negative infinity.
Uh-huh. Until you get to A. So how about decreasing? What's going to start decreasing at that X value of A where it's going downhill, and it's decreasing as I head towards
Positive infinity.
positive infinity. So look, on your parabolas, one will go from negative infinity to that X value. The other will go from the X value to infinity. Both of these have the same pattern. It's just figuring out, are you looking at a minimum or are you looking at a maximum there, okay? All right, y'all. So they're going to add a little bit to this one. So watch what we got going on. I'm going to find the vertex. I'm going to find intervals of increasing and decreasing. Determine the min or max value. And find the range. Alrighty, so here we go. This one, they're giving me f of x equals. Now, there's two of these. I'm doing one of them. And the one I'm doing is the one that ended up with the fraction. Now, the other one won't have a fraction like this one. Y'all, let's see. I got negative 4x squared minus 20x plus 9. Now, that's a negative a on this thing. A is negative 4. B is negative 20. C is 9. First question, minimum or max? All right, y'all, let me see my chat's lighting up. Let me see what they're saying. So definitely maxes. Good job, y'all. So we know our parabola is going to have a maximum. So let's get that vertex. So finding the vertex will answer a lot of these questions, and it really gives me all the information I need for everything here. So I'm going to get that x value. So negative b over 2a will be a negative times negative 20 over 2 times negative 4. So y'all, let's see, that's going to give me a 20 on top, negative 8 on the bottom. Well, that's going to end up negative. Now, the biggest number you can divide out of both of these is a 4. If you did 2, you'd get 10 over 4, and you'd have to do the 2's again. So the biggest factor they got in common is a 4. So I'm going to end up with a negative 5 over 2. So that's the x value. Now I'm going to get the y value by finding f of that negative 5/2. So that'll be negative 4 times negative 5/2 squared minus 20 times negative 5/2 plus 9. So remember, I'm doing the exponent first, so I'm going to bring down to negative 4. Now remember, there's really 3 negatives here, so we know in the long run this thing will end up negative. So negative 5 times negative 5 gives you 25 over 4. And I'm just going to bring everything else down. But y'all, I like this one because a lot of stuff's about to simplify. Now, you see these 4's technically cancel here, right? So watch this. -4 times 25 is a -100. -100 divided by 4 is a -25. Or you can cancel these 4's out and make that a -1. Either way. -1 times 25 is still -25. Like right here, you can multiply and divide. -20 times -5 is 100 divided by 2, which will give me 50. Watch this, y'all. This -20 divided by that 2 gives you a -10. And -10 times -5 makes that a positive 50. At the end, bring down to 9. Now, are y'all noticing something on these? Every time I've got to this point where I was about ready to add, when you're looking for the y value, are you always noticing the second number is always opposite in sign than the first one and twice as big? Just little patterns you'll see on these. All right, so let's add -25 and 50 is 25 plus 9 is 34. So y'all, I now know my vertex point right here has the x value of -5/2, and it has a y value of 34. So, intervals of increasing and decreasing. So let me do the increasing. Well, y'all, remember, that's a max. So it's increasing on the left side. And remember, we had a picture a while ago that said if your graph had a maximum, the increasing is coming in from the left side and going to that x value. So you're starting at -infinity. You're cruising along the x-axis until you hit the x value of -5/2. The right side is decreasing. Well, y'all, if this side came in from -infinity to that x value, it's decreasing from that x value to positive infinity. When you're dealing with parabolas, one will always have a -infinity, the other one will have a positive infinity. All right, y'all, min or max value. Well, we said it was a maximum. And it has a maximum value of, where's my y value? 34. Now, here's the last one for this. They wanted my range. All right, y'all, I'm looking at one thing real quick here. All righty. Now, the range is the y values. Well, we know the highest y value here was what? 34, right? So if 34 is my highest y value, now for the range you always want to start at the bottom and head upward. So remember, because this graph goes down forever. So if you're looking at the y values and you're coming in from the bottom, where are we coming in from? Because remember, the y values are positive up and it's negative headed down.
Negative.
Negative infinity. Good job. And you're cruising up the y values till you get to that y value of
34.
34. Now, y'all, here's the one thing that's going to be different from while ago. That 34 is actually included in the range. So you got to put a bracket around that 34. Remember, brackets include the numbers. The reason the intervals don't, well, can this same point be both? Can -5 be increasing and decreasing? No. That's why you got the curvy points, okay? Because that tells me at the -5 is where it's crossing over. So the range has to have a bracket around that number. All right, y'all. So they just up it by adding one more thing into it. So let's do a word problem that deals with this formula. Now, they're going to give you a big, long sentence that says a toy rocket is shot vertically into the air from a launching pad 3 feet above the ground with an initial velocity of 64 feet per second. It says the height, h, in feet of the rocket above the ground at t seconds after launch is given by the function. So what you need to know is the function they're giving you is h of t equals -16 t squared plus 64t plus 3. Now, all of y'all will have the -16t squared. What'll be different is the 64 and 3. Yours might not be going 64 feet per second, and your launching pad might not be 3 feet above the ground. But the -16t will be the same because that's gravity. Now, let me see what they want on that one. They want to know how long will it take the rocket to reach maximum height. Then they want to know, what is the maximum height? Well, y'all look here. T is the variable here. That means the T is like the X variable. So when it asks me how long will it take, it's looking for time. That's going to equal my X value. And then the maximum height, which is what the formula's finding, that'll be like your Y value. And we're going to do our vertex. Okay. So this one would be like our T, which is our X value, and then our H of that T will give us the Y value. So y'all, let's find A, B, and C. Because what they got, when the rocket is being shot off, the rocket's going to start at 3 feet. It's going to go up, up until it reaches a maximum height. Then it's going to come back down. So we're still basically looking for our vertex on this. So let's see, A is -16. And that makes sense. Negatives have a maximum. And we're looking for a maximum height. B here is 64. And C is 3. So X value. -b over 2a. So that's going to be a negative plus my 64 over 2 times negative 16. Now remember, time is positive. So when you're done with this better be a positive number, okay? So I got negative 64. Bottom is negative 32. And y'all, that actually comes into what, a positive 2 for me. So how long will it take my rocket to reach maximum height? 2 seconds. Oh, so it takes 2 seconds to reach max height. So now I'm going to find the y value, and that's going to give me that maximum height. So I'm finding h of 2. So that'll be negative 16 times 2 squared plus 64 times 2 plus 3. All right, let's see here. 2 squared is 4. 4 times that negative 16 gives me a negative 64. And then this 64 times 2 gives me a positive 128. And then my plus 3. So y'all, I just squared that and multiplied in the same step. 2 squared was 4. 4 times negative 16, okay? Then I multiplied that. Now let's see what we get. Negative 64 plus 128 is 64 plus 3 is 67. So my rocket has maximum height of 67 feet. Now, MATLAB will have the feet. You're just putting in the 67, and then you're just putting in the 2 for the seconds. It'll already have the words for you. So 67 feet, that's probably what, 5, 6, 7-story building. So I guess it was all right from a rocket. All righty, question on those. All right, y'all. So I'm going to share my screen real quick for the support stuff. So let me make sure MATLAB's still open. All right, let me get back into MATLAB. I timed out. Oh, I think I timed out everything. Okay. All right, y'all, hang on 1 second. Let me get my MATLAB pulled back up. Now, this is just 3 problems doing the intervals of increase and decreasing and constant. So let me get to that. Let's see, we're what, 7.5. All right, I've almost got this first one pulled up for us. All right, y'all, so I'm going to share my screen here. And I'm going to make the graph a little bit bigger for us to see good. So y'all, you got A, B, C, D answers there. On one interval is this graph increasing. So that's the very right side of it over here, where the arrow's going uphill to the right. So it's increasing at that point where it's going from horizontal to uphill. What I need is that X value. Well, y'all, that looks like 1, 2, 3. Y'all with me? If I'm at 3 on the X value, that's where it starts going uphill. And as you cruise out to the right on the X's, it's going uphill. So it's going from 3 to infinity. And remember, parentheses on the intervals. So good job, y'all. Definitely C. Good job, Caitlin. I'm going to leave my chat over here where I can watch it. All righty. So you would check that answer. So then it says the function is constant on what interval? So y'all, constant is this straight part. So what I want, A, B, C, D, I want the beginning X value and the ending X value. And really, we know it can't be A and D because they got the wrong brackets. So y'all saying C again, let's see. So yeah, it starts at -3 on the x-axis and goes to +3. So you're looking at C on that. All right, y'all, you're going to check that. Then they're probably going to want that decreasing, I bet. So decreasing to the left side, y'all, A, B, C, or D. All right, where'd my chat go? My chat left me. All right, so I'm getting some B's in here. I'm getting a lot of B's. And y'all, that's it. Remember, coming in from -infinity to that -3. Good job. And if you notice, these intervals we just got will all connect. From -infinity to -3 was decreasing. -3 to 3 was the part in the middle, constant, and then 3 to infinity. So they all sort of hook up when you're done. All right, making that enlarged so we can see. So what intervals is it increasing? And y'all look at this. I'm going to look at the 4 lines. The first line is constant. Second line is going uphill, increasing. Third line is downhill, decreasing. But the fourth line over here is going uphill. So you got 2 places it's increasing. So y'all going with C or D? So we got to look at this first one and get that point and go straight up on the x-axis. So it looks like that one's starting at -5, and I'm going to go down the x's until I can find where it stops. And y'all, it looks like it's stopping at 1. So let me see what my chat's saying. So y'all are saying C on that one. Yeah, because it's that -5, 1. And then the second part starts at 6 on the x-axis and goes to 9. So good job. So y'all C is definitely right on that one. So y'all, these aren't bad if you focus on the x's only, okay? So decreasing was that third little line there. So do y'all want to, I'll let y'all give me this answer and I'll wait on my chat. Let me pull my chat up. So we want to know, where is this decreasing from? And y'all, I don't think it'll let me make that any bigger.
From like the third point
I'm talking
right there.
about the third line, that when it sort of goes downhill left to right where my cursor is here.
Mhm.
So I'm looking at the x value right here. So I'm going to go down and touch my x-axis. And that would be where 2 is at, right? So it looks like
Right.
my chat's lining up. So you would put a 2 for where it started at. And then over here at where it almost looks like a V point, that's where it stops going downhill. So I would go up to that x-axis and see what that point is. And that looks like 6. So from 2 to 6 on the x-axis, it was going downhill. So good job, Chad. So y'all would answer that one. Now, where's it going constant? Where is this line going straight across? So where the black dot is, I want that beginning x value. Where the hollow dot is, I want that ending x value. So the black dot, what's that x value, y'all? That's what? 10, 9, 8. All right, chat's lighting up again. Let's see. So I got -7 on that one. Good job. So that would be -7. And it's only going 2 over to the -5. Good job. So y'all see what if I touch my x's at -7 to -5, definitely constant. All right, y'all. So I say the best for last. So increasing, and I will say this, there's 2 places where that's increasing. I'm gonna make it a little bit bigger. First, that sort of parabola looking part, it's increasing on the left, and then it decreases, then it goes constant, then it increases again, then it goes constant again. So my first interval, I'm going to put my parentheses. It's increasing on this left side of the parabola. It's coming in from -infinity.
And -7.
And -7, perfect. Now, put a comma, and then let's do the next one. So the next one is this little slanted line to the right. So I need the x value where it starts going uphill. Y'all, let's go straight up. That looks like -2 there, right? And that little bitty, that little slanted line stops at -1. Good job. Good job. Perfect. So from -2 to -1, and then close my parentheses. So two points going uphill, you got to get them both. So then it'll make y'all check that. So let's look at decreasing. Well, y'all, we only had the one part decreasing, and that was the right part of my parabola there. So where does it start decreasing at? And where does it end? So y'all, let me see.
-7.
Okay, yep, -7, because if I come straight down, I'm actually at -7. Good job. So let me write that in there. And then it ends down here where it starts going straight. And that looks like -5. And then close my parentheses. All right, good job on the chat. So then you got constant. There's 2 places where it's constant. So I'm going to go left to right, y'all. This first one starts at that looks like it starts at that -5. And it's going to the right constant until I get to the point where it starts going uphill. And y'all, that started going uphill at that -2. All right, comma. And y'all, this next one's on y'all. This long line on the top going to the right. All right, Vidi, you got the first one. Now get me that second one. It's going all the way across the top of this thing. Oh, y'all, so I'm trying to find my messages. Oh, look at y'all. -1, perfect. It starts at -1. And y'all, good job, Nancy. That thing goes towards infinity. Good job. So -1, comma, infinity, and close. And y'all, that's the trick on your support. Make that graph bigger if you got to. So that you can see them X values really good. If you want to zoom it in, do that. But that support was just to get you good for those couple problems you got in college algebra, okay? Now, I'm not going to lie. Get good on those intervals because next week, when we do 6.8, it'll have a little bit of this intervals of increase and decreasing and all that fun stuff. All righty, so a little bit of a long lecture, y'all, but I wanted y'all to see a lot of problems dealing with that vertex, okay? I'm going to quit my recording.